Today, we'll explore how to easily integrate the functions of sine and cosine with the examples shown here. As always, we'll be using the box rule. If you are new to the box rule, please click on the link at the top right corner for detailed explanation of this method. If you watch this video until the end, you'll be able to solve this problem in just 2 lines. First, let me explain the box rule for the sine function. If the integral has the form of sine box multiplied by differentiate term of the box, which is the box prime, then the answer is simply a negative cosine box plus c. In other words, you just need to plug in the contents in the left green box into the right green box. The integration of cosine function is also the same as sine. If you find the cosine box and the differentiated term of box, which is the box prime, the answer can be simply expressed as sine box plus c. Easy, right? By the way, there's a link on the community tab of my YouTube channel where you can download the box rule formula table. If you need it, please visit my channel and feel free to get it. Let's start with a very simple problem. You may already be familiar with this problem, but I will explain how the box rule is applied. Here's the box rule. What should go in the green box? And what about the box prime behind it? We can see that we need to put 5x in the green box. And for the box prime behind it, we need 5, which is the derivative of 5x. So let's put 5 in the box prime. Just like on the left, we need to multiply by 1 over 5, so let's make some room. We can multiply by 1 over 5 and put 5x in the green box to get the answer. The second example is not difficult either. Let's solve it in one line. We can put e to the power of x in the green box. E to the power of x is derivative in the box prime. And finally, put e to the power of x in the green box on the right to get the solution. This problem may seem a bit more complicated. Let's try to separate the expression in the fraction into the product of two terms. Oh, on a closer inspection, the derivative of ln x is 1 over x, and it was multiplied right after the sine box. Exactly what we want, right? Then let's put ln x in the green box, 1 over x in the box prime, and finally put ln x only in the green box on the right. That's all we need to do. This example has sine, cosine, and tangent all together. As expected, since it is a form of a fraction, let's try to express it as the product of two terms by using the fact that 1 over cosine square x is secant square x. Here comes the box rule. You all know, right? The fact that the derivative of tangent x is secant square x. So it is already determined who should go into the green box and the box prime, right? Put tangent x in the green box and secant square x in the box prime, and put tangent x in the right green box to complete the problem. Now we can see a pattern emerging, right? This problem can also be solved in one line. The sine x in the box, when differentiated, gives us the cosine x in the next box. So we are done. We put sine x in the green box, cosine x in the box prime, and finally sine x in the right green box to finish it off. Now let's solve this killer problem in just 2 lines. Although the problem seems very complicated, let's separate it into cosine arctangent x and 1 over 1 plus x squared, just as we did earlier with the fractions. Okay, now do you see something? What's the derivative of arctangent x? Yes, it is 1 over 1 plus x squared. That means we need to put arctangent x in the green box and 1 over 1 plus x squared in the box prime, and then simply put arctangent x in the right green box to get the answer in just 2 lines. Alright, here's a bonus question. What? A bonus question in math? Yes, I know. But listen, this is a problem my students often make mistakes on. Do you see sine box and the box prime? No, you don't. Instead, you see 1 plus sine x to the power of half. That's the box. So you're gonna use the basic box rule. If this method is new to you, please refer to the basic box rule video at the top right corner. Let's apply the basic box rule, and we see that the green box should have 1 plus sine x, and its derivative cosine x should be nicely multiplied at the end. So we'll put 1 plus sine x in the green box and cosine x in the box prime right after it. Let's put 1 plus sine x in the right green box as well, and the exponent will be half plus 1, and that value will also go in the denominator. Let's refine the answer a bit. To simplify the derivative in the denominator, let's multiply both the numerator and the denominator by the denominator value of 2. then the answer becomes 2 times 1 plus sine x to the power of 3 over 2 over 3 plus c. Okay, we're almost done. This is the final problem. Although there are sine and cosine functions in this problem, we need a different approach. If we differentiate the denominator term, does the numerator term come out? If so, you need to use the box rule for fractions. The link to the box rule for fractions video is available in the top right corner if you need it. Since the derivative of denominator 1 plus sine x is the numerator cosine x, we'll put 1 plus sine x in the green box of the denominator and cosine x in the numerator. Then the answer is ln 1 plus sine x plus c. Alright, today we learned how to use the box rule to easily integrate sine and cosine functions. I will continue to create helpful videos for your learning in the future. Please subscribe and like, and have a great day everyone. This has been your Math Guardian, Alex.